Folks, let's fire up those Chromebooks to 8-6. 8-6. That was our weekend assignment. Hopefully, while you are doing these reactions, we talked about the steps to go through. First, we were hoping that you would be able to look at the reaction, balance it, then watch the video which demonstrated it. And then, of course, there was an easy way to check if you balanced it correctly, because like 8 out of the first 10 of these, you had balancing help videos to go with it. So you were asked to balance the reaction. If you had trouble, click the balancing help and then watch the reaction. I mean, it's kind of fun to actually see these. There were some outstanding demonstrations to watch to kind of bring these reactions to life for you. What kind of questions did we have? We were identifying the reaction type, balancing the reaction. Let's just kind of go through, give you an opportunity to ask questions on any of these that might have presented difficulties, confusion. Obviously, when there's balancing help, if you really wanted to, and I never know, you could just click on the balancing help, get the answer, type it on there. I would never know. But that would certainly be a method that would give you no practice balancing these. Learning to balance is kind of a practice thing. The more you practice it, the better you will get at it. Patterns will begin to emerge and so forth. Any questions on that first one? How about down here? Questions on, is that number 2 right there? Questions on number 2. This one we didn't have a video on. How about this one? Questions on number 3. Why is this one not called acid-base? This was not designated as an acid-base reaction. There's an acid right there. Yes.
What's the net ionic?
Net ionic is another name for double displacement because it's a net ion exchange. Because these are ions right here. Fe's 3+ right here. The bromide's 1-. Over here, the bromide will still be 1-. This will be 1+. You're going to make HBr, which is also a ridiculously strong acid. The sulfide ion's 2-. This is 1+. So what ends up really happening in this reaction is the sulfate ion ends up with the iron. And if we notice, their charges did not change. See how that 3 came from there? That's 3+. That 2 was crossed down from there. That was 2-. So all that happened is the ions really exchanged partners. So that's just another name for double displacement. Net ionic exchange. Some people say double replacement. All kind of the same term for the reaction. How about right here? How about right here? Combustion reaction. They reminded you to use the Hollister rule. And it gave you the 2 parts of the Hollister rule right here. HCO, Hollister Company, even number in front of the water. A lot of people had trouble balancing this one because when we started, there was no 2 there. And when you look, there was no 2 there. And a lot of people would say, oh, there's 2 hydrogens there. There's 2 hydrogens there. They're balanced. I don't need to do anything to the hydrogen. Well, when there's no number written in front of the water, it's understood to be a 1. 1 is odd. When there's no coefficient, the coefficient is actually 1. There is a coefficient. So instead of a 1, you have to double it and make it a 2, which means you now have 4 hydrogens, so we need a 2 there. 2 times 2 for carbons is 4. We put a 4 there. 4 times 2 for the oxygens gives us 8 oxygens there. 2 times 1 is 2. 8 plus 2 is 10. We need a 5 in front. 5 times 2 is 10. Some of you did balance them. You didn't really check them because there wasn't an answer key posted. But if you really were wanting to check to see if you balanced it right, click on the balancing help. Then we did another combustion again for practice, the reminder on the Hollister rule. And this is one where originally we would try to put a 5 there, because if we have a 10 here, the first number we would try to put there is a 5. 5 times 2 is 10. But we need an even number in front of the water. So what do we do to that 5? We double it to make it a 10. 10 times 2 is 20. So we need a 2 here. 2 times 10 is 20. That gives us how many carbons now? 2 times 4 is 8. We put an 8 in front. Carbons are balanced. We did hydrogens first, carbons second. Oxygens are third. 8 times 2 is 16. 10 times 1 is 10. 10 and 16 is 26 oxygens. We put a 13 in front. 13 times 2, 26. That Hollister rule was just a made-up rule. There's no such real rule there. I doubt you would ever see that in a chemistry textbook. It's just a rule I kind of invented as a way to make it fast and easy to balance these. This is acid-base, which is really a what? Acid-base is just a specific type of, yes, absolutely double displacement. Well done on a Monday morning. Because what is really happening here? Double displacement. The hydrogen. I'm trying to highlight this. I'm having a little trouble. There's a hydrogen. Oh, I'm still troubling. Hydrogens right there are joining with the hydroxides right there. So the H's here are joining the OH's there. First thing's joining with the second thing to make HOH, hydrogen hydroxide, which is water. 2 H's, 1 O. That's water. These are very easy to balance because if we have 3 hydrogens here, we're going to need it to join with 3 hydroxides to make 3 waters. We have 1 phosphate. If we put a 3 in the front, that gives us 3 potassiums. It turns out that we would need those 3 potassiums because when we crisscross, potassium's 1 plus, we bring the 1 down to the phosphate ion, we bring the 3 down there. So by balancing the hydrogens and the hydroxides, the rest of the reaction will fall into place. Some people prefer to balance it the other way. They're like, wait a minute, if this is 3 minus, this is 1 plus, crisscross, that's 3 potassiums. So I need a 3 in front to give me 3 potassiums. You see, it doesn't matter which way you go. You're going to get the same result. We have 3 potassiums. Okay, 3. 3 goes there. That gives me 3 hydroxides, which means I need 3 hydrogens to join up with them. Oh, I've got 3 hydrogens right there. Did you already join up with them? And that will make 3 waters. Acid base. Here's my acid. Acids lose the hydrogens. They're gone. The base is the hydroxide ion. It accepted the hydrogen to make the water. This was kind of a fun one to watch as well. These demos were pretty good. I think you really enjoyed these if you watched them. It was hard to only watch them one time. It was hard to watch them one time. I'm guessing a large number of you probably binged Chemical Reactions this weekend. Did you not? Like, you started clicking on these different demos, you watched them, and then you're like, I want to watch more of them. And you realize that there are tens of thousands of chemistry demos that have been taped and put on there. Fantastic. Fantastic. In the age of binging, this is probably going to become like the number one binged shows on all of the internet, YouTube, whatever. Question on this one, number 7. Then there was a neat little thing here on acid rain, an environmental problem. Little video explaining acid rain. Then we learned the chemistry behind acid raining. Acid rain. We learned the chemistry behind that. Questions on any of this part? This was a little neat thing, like seeing chemistry in the real world. It was captivating, mind-boggling. Then we learned a little bit about fool's gold. Why was this really oxidation reduction? In a sense, also a combustion reaction in a way. It's just not the combustion of a hydrocarbon. It's not the combustion of a hydrocarbon. You see why it's not single or it's not double? In combustion reactions, in the presence of oxygen, the oxygen joined the sulfur, and then the oxygen also joined the iron. So we had oxygen joining two of the things. That's oxidation reduction reaction. What's oxygen's oxidation number right here? When it's by itself. An element by itself. No charge. And not an ion, an element by itself. What charge? It's always what? It's always 0. Oxygen's the second strongest of all the elements, so it gets its 2- every time, or -2. Every time it's with another element other than oxygen, not the peroxide ion, because it's with an oxygen there essentially, and not when it's with fluorine, which is the strongest. Here, it's actually 2-. It has a charge. Here, it's -2 because it's not ionic. Here, it's with the metal, it's ionic. So you can write a 2- there. It's fully charged. But if it's charged fully -2-, its oxidation number is -2. So it goes to -2. Let's see what happens here. Iron right here has an interesting charge. It's with sulfur. This is kind of a strange compound. But sulfur right here gets its minus. Here it's now with the sulfur, it would go to +2. So sulfur goes from minus to +2. The oxygen goes from 0 down to -2. You see that? Oxygen goes from 0 down to -2. It was reduced. Sulfur goes from minus to plus. Its number went up, minus to plus. It's said to have become what? If your number goes from minus up to plus, if your number increases, you're said to be what? Oxidized, yes? You're said to be oxidized. The oxygen went from 0 down to -2. Its number was reduced or lowered. Do you see why they say the term oxidized? Who is the culprit of elements' numbers going up a lot? Who made sulfur's number go up? The oxygen did. Thus the term, it was oxidized. Iron here was plus, and it also went down to minus. It also went down to minus. Or oxygen was plus here. Yes? I said this wrong. Oxygen was plus right here. It's going to remain plus, but now it's with oxygen instead of the sulfur. What about the next reaction? This one was not an easy one to balance, and did you get help on balancing that one, number 10? There is some balancing help here. This is an interesting little website. You didn't get this website on your homework because I wanted you to balance this one without any assistance. This was a challenging one, a fun one indeed. But there is a website out there called ChemEquations. I'm telling you this only for your resource. There's a website called ChemEquations where you can type in an equation and it'll balance it for you. You're like, why are you telling us that? That would make it very easy for us to cheat. If you don't try to balance these on your own when you're asked, you're cheating yourself. You really are. But if you ever get in a struggle, like how do you know when you should go to a ChemEquations website? I did not give that to you on purpose. How do you know? Because you've tried to balance it. These are fun mental challenges. Balancing is a fun, exciting mental challenge. It's solving puzzle is all you're doing. You're solving a puzzle. How do you know when it's time to give up? When you can't cry anymore. When you have no more tears left in your eyes because of frustration. When you've tried a couple times and you're waking up every hour of the night. You're just sitting up in bed. You don't have the equation balanced yet. You're like, I've got to solve this. I've got to solve this. You're up. It's like 3 a.m. You're like, I just thought of something. And you try it. No, I don't know if that worked. Oh, it didn't work. You go back to bed again. 5 a.m. You're up trying to balance it again. Why? Because you have a passion. You have a passion to solve a problem. But when you've done this for several days where you can't eat because you're so stressed, you're having trouble eating, you're running into walls in the hallway. Why? Because you're so lost in thought on balancing that you're like running right into walls. You're like, what just happened? I didn't know I walked right into a wall because I was so lost in solving a problem. You're getting near that point where you might need to check ChemEquations. You haven't gotten there quite yet. Like prom is next weekend, is it not? And maybe you have a prom date. And you forget to pick your date up for prom. Why? Because you're lost in trying to solve the equation. You're nearing that point where it would probably be time to check ChemEquations. Little website for you, chemequations.com. This one was a little tricky to balance because you had oxygens here and here. And you had oxygen here, here, and here. Oh my gosh. That's lots to balance. I would certainly save sulfur for last. Why? When you have an element by itself on one side of the equation, you save it for last. This one was also a very interesting one to try to balance. Again, you did not get help on that one on purpose. Looking at the answer is a last resort, and often the time you look at the answer is when you think you have it, when you think you've solved it on your own. Then you can always double check. That's a time to look at something like ChemEquations or Google it or whatever. We did have people solve these in this class. That is fantastic. I hope you enjoyed the ride. Some of you might have gotten it very quickly. Why? Young minds are good at solving. How many of you were able to balance these in like 5 minutes? Under 5 minutes. Anybody? Under 5? 10. Do I have 10 minutes? Anybody about? You got about 10 minutes. About 10 minutes. That's really good. That's phenomenal chemistry. That is great. That is higher order problem solving, manipulating things. By the way, one of the math teachers, Mr. Mitter, walked in my room, and he's like, you know that if they know how to use their calculator, they can balance these as well. How many of you know how to use your calculator to balance them, where you just set up a little matrix on your calculator? Your calculator will balance them. So if you ever need, like, that is a fun thing to learn to do as well, to use your calculator to solve them, but not in a trade-off for learning to use your brain to solve them. When you can solve this stuff, folks, you are a great problem solver. You should be proud of yourself. Those of you that were able to get these, that is a fantastic thing. Any questions on any of this? Let's talk about what's happening the next 2 days. We have so many of you taking the air test Tuesday and Wednesday. Are you supposed to have a half hour if you're taking the air test? Are you supposed to have a half hour of homework in your class every day as well to do on top of the air test? I don't think you're supposed to have your teachers assigning additional assignments on air test days. So that's the interpretation I have. When I read it, if you're not taking the air test, you're not supposed to have homework because you just grinded out 3-4 hours of testing, time to rest for the next day. Yes? We are not making additional chem assignments. So if you're a junior, you're like, wait a minute, I'm not taking the air test. I should have a half hour of work. Well, this class has like a large percentage of sophomores in it that are taking the air test. I'm not going to give the juniors work to do and then the sophomores have to catch up later. That's just not fair. So what we're going to do, and if you read your email, check your school email. Ladies and gentlemen, we have a reprieve on late assignments. What is a reprieve? What does that mean? I say we have a reprieve on late assignments. What do I mean? Is Unit 7 supposed to have already been turned in and I won't accept it anymore? Correct. But now we have air testing. And I'm like, that's not a good use of time to tell you to do nothing for 2 days. So if you've gotten behind and you are missing assignments from Unit 7, I'll still take them. Today and tomorrow, a reprieve. No penalty for late assignments. Wednesday through Wednesday night, we will take them. Today, tomorrow, Wednesday. So if you want to get caught up, if you want your participation points for Unit 7, you can still earn those. If you're already caught up on Unit 7 and you're missing assignments from Unit 8, get caught up. We are down to like, what are we, week 3 already? Of 8 weeks, because the 9th week is exams. Don't let yourself get too far behind. Get caught up if you're missing work from Unit 8 and especially Unit 7. If you're missing work from Unit 7, think of the opportunity you now have. The participation points weigh heavily on your grade. Go back and get Unit 7 caught up. Just grind it out. Today, we are doing something interesting. Today, we are going to write and balance chemical equations, except you're not going to be told the products. This last weekend, you told me the reaction type, and they gave you the equation. You had to tell me what the reaction type was if you looked at the equation. Now we're doing it differently. Now, what are they going to do? They're going to tell you the reaction type and not give you the equation. You see that? What did we do this weekend? I gave you the equation, you told me the type, and then you balanced it. Now I'm telling you the type, and you're going to write the equation and balance it. There's going to be some videos which help you to learn to do this. In the videos, they do not balance the equations. They just tell you how to write the equation if you know what type of reaction it is. That's what they're going to teach you to do. You are expected to balance them. Now, for this particular assignment, I have posted an answer key. Would you benefit best by trying to write it and balance it yourself, then look at the answer key? 100%. 100%. You've got to learn to govern yourself and do things in the way that they're intended. Don't try to make this easy. There is no quick way to learn to balance other than doing it yourself. So 8-7 should have been posted. Is it posted on Google Classroom? Good luck, students. This is fun as well. It is really fun to know the reaction and write it yourself. It's as much fun as to be given the reaction and try to figure it out what kind it was and then balance it.